0, a number. This is the y-intercept, and this is the wise thing to do. Can you use the other formula, the point slope form? Of course. Will you get the same answer? Of course. But this is the easiest when you have the y-intercept. Okay. Let's graph a line to refresh our memory on how to graph a line. And let's say 62 on 267. We are given 4x plus 6y plus 12 equals 0. My math lab may ask you to use the slope in order to graph. I will not. I will not ask you to use the slope. And here's the question, if you ask me why. Here's my answer. This is the only function, the only equation that you can use the slope to graph. So forget about it. It's not a good method. It's not applicable in any other situation but this one. So I will never ask you to graph using the slope and the y-intercept, ever. The only question that I have, and to any function, is to graph using x and y-intercepts. X-intercept and y-intercept. How do I find the x-intercept for any function?
You want to see what y equals 0?
Correct. For y-intercept, I have to make y equal to 0 because the x-axis has the equation y equals 0. Y equals 0. So all I have to do not waste your time to solve for y. Don't. There is no need for something like this. If y is 0, this is 0. Can you tell me how much is x when y is 0? Remember, imagine that you have to move 12, or you just write it. Move 12 to the other side and divide by 4. Correct. That's all you need. So what is the point that we just determined? Excellent. Thank you. Awesome. 4, just write it down. 4x plus 12 equals 0. Move 12 to the other side. And how do we get x? No, I wanted you to see it.
4x equals 12 then, right?
Negative 12. When we
Or
move a
negative
term
12.
from one side to the other.
Yeah, so when you move 12, you're going to have 4x equals negative 12, right? Okay. And then you have to divide 4 from x. So that's how.
We divide both sides by 4.
Yep, and that's how you get negative 3.
Better? Other questions for me? Is this okay, everyone? Yes? Okay, so now for y-intercept. What do I have to do in order to find the y-intercept for any function?
X is 0.
Exactly. Because the y-axis has the equation x equals 0, right? So when x is 0, please solve the equation and tell me how much is y.
Negative 2.
Do you all agree with negative 2? Very good. And let's write. That's why it's important to write it at least first time, and then you will see it all the time. So what is the ordered pair that we just determined?
0, negative 2.
Very good. So let me refresh your memory because I think I said it fast and I want to write it for you. The equation of this line is y equals 0. That's why when we wanted to determine the x-intercept, we set y equal to 0. The equation of this line is x equals 0. That's why in order to find the y-intercept, we set x equal to 0. So now we plot the points we have and extend the line. That's it. 0, negative 2 is this point, and negative 3, 0 is this point. Connect and extend the line. Always write, please, always write what you graphed somewhere. 4x plus 6y plus 12 equals 0. Any questions on this? Yes, please. Yes, please. I'm sorry?
This is just finding the x and y intercept.
Yes, I'm not going to ask you to graph using the slope. It doesn't work for anything else. Okay, let's say now I would like to graph x plus 2 equals 0. What do I have to do? I want to graph this.
It's just x equals negative 2.
But it's not a point, it's a line.
Right.
So we have to be careful. What type of line is it? Remember, x, exactly, x is the position, y is the altitude. Correct. Very good. Just remember that. Good. So at -2, this is it. X equals -2. Let's say we want to graph y equals 3. How will I graph y equals 3?
A horizontal line.
Very good. Yes, right here. This is y equals 3. I need this a lot for chapter 3, when we are going to discuss way more sophisticated functions, how to graph them, and so on and so forth. Okay. On page 279, let's look at problem 6 and also problem 8, 279. Okay, 6. -2, -7, and parallel to the line y equals -5x plus 4.
Is that number 8 or number 6?
6 first.
Number 6.
They're very similar. Okay, so what are we asked here? Let me explain from the beginning. We're asked to find the equation of a line that passes through this point and is parallel to this line. So let's come up with a little graph. This does not graph this, does not graph the line, nothing, just the idea. This is just the idea. Let's say I have a line whose equation I don't have, but I know two things about it. I know that it passes through this point. So somewhere along the line, I have this point, -2, -7. That's the first piece of information. It passes through that point, and it's parallel to this line, y equals -5x plus 4. So the question is asking us, this problem is asking us to find the equation of the blue line. Well, I have a point. Is this point the y-intercept? Yes? No. So then I have to think at y minus y1 equals the slope times x minus x1, where I have -2 and -7. But I am missing a piece, a very important piece of information, without which I cannot determine the equation of the line.
-5.
How do I know that the slope of this line is indeed, let's say m2 equals -5? Because I know that m1 is correct. And because I was able to read it from y equals mx plus b, which gives us the slope of the given line to be -5. Since the two lines are parallel, and I established that the green line has slope -5, the blue line has to have slope -5 as well. All I have to do is put in all the information and determine the equation of the line. It's slightly more difficult when the given information or the problem or the line that we are looking for is not parallel, but what is the other one?
Perpendicular.
Perpendicular too. And that's number 8 in a minute. So let's finish this one. Remember, negative changes into positive. That's why I wrote it like this, so we can see. So x plus 2. -2 changes into positive. I distribute -5x. This will be -10, and I bring us -7.
Y equals -5x minus 17.
This is the equation of the blue line. And I guarantee you that it passes to this point, because we used the -2 and -7, and it has the slope -5 as we see. Now, if I ask you, what is the y-intercept of this equation, what will you say?
0, -17.
0, -17. Any questions on this? Any questions? Okay, let's look at number 8. Same question, basically. It passes through -4, 2, and it's perpendicular. This is a sign for perpendicular to the line whose equation is y equals 1/3 x plus 7. So now the idea is this, right? We have a line, and we know two things about it. Here's one, -4, 2. It passes to this point. But now it's not parallel, but perpendicular to a line whose equation is y equals 1/3 x plus 7. So now the question is, what is the slope m2? Since m1 is how much?
1/3.
Very good. How much is m2? Remember, the product 1/3 times something else has to equal -1. 1/3 times what is -1?
Just know that to change the sign. So I would just say that it's -3.
Exactly.
I'm having trouble training my brain to think of it.
Yeah, 1/3 times -3/1 is -1. Exactly. Any questions? In the same way, same equation. Is this the y-intercept? Say it again, Priscilla, go ahead.
I don't. It's okay. You can move on because I don't even understand that concept.
How to get the slope of the perpendicular?
It had to do with -1, but I forgot what. I guess
Right here. So, see, if this number is 1/3, this must be -3 for the answer to be -1. So if the slope of one line is 1/3, the other one must be -3. Only 1/3 times 3/1 with minus in front will be -1.
So it's always going to be n1 times n2.
That's the relationship for perpendicular. We can never change that. So if one slope is 2/3, the other one has to be -2/3, -3/2. If one slope is 5, the other one has to be -1/5. If one slope is 1/7, the other one has to be -7. So then the product is -1. If you want to think in those terms. Or the other one, right? m1 equals -1/m2. But then if you have a fraction, then you have to flip it. You have to be careful. That's fine. Both work fine. So then we have y minus y1 equals the slope times x minus x1. And we have -4, and we have 2, and we have -3. Is this better, everyone, please? Is this okay so far? Please ask any question. Okay, so again I have to solve for y. So y minus 2 equals -3x plus 4. We distribute -3x minus 12, and we add 2. -3x minus 10. What does this equation represent? One more time, can anyone tell us what it represents? The equation of the line that passes through -4, 2 and is to the given line. Excellent. Excellent. Yes, please.
So for number 8, has
Yes.
the equation, the actual equation. That equation will always
You're talking about this one?
be a perpendicular, yes.
This is the points.
Not the other one, from the actual equation that we worked on, because that's all one question, right?
Yes.
Eight.
So we are asked to find the equation of the line passing through
Yeah,
this
right.
point and perpendicular to this line. That's why I created a
that's
scenario.
perpendicular to that. Okay. See, that was-
Yeah, so I created a scenario for everyone to see. This is the equation of the line we don't have. It passes through -4, 2 and is perpendicular to the orange line. We have to determine the slope of the green line in order to determine its equation. Is it clear how we determine the slope of the green line? Any questions? Is this better? Is this okay?
Yeah.
Other questions? Anyone? Is that clear now, everything? Yes?
Yeah.
All we did was, you understand how we got the -3?
Yeah, because you're trying to make it equal to -1, right? I mean, you're trying to make it equal to 1.
So I have this slope of the given line. So this is m1 times m2 equals -1 because they are perpendicular. m1 is 1/3 times what number is -1? And that's how we get the -3. 1/3 times -3/1 will be -1. So once we get the slope, we only have to put it in the equation, and we do have the point. We had -4, 2, and the slope was -3. Is that better, everyone? Okay, so the last thing that we need to look at in this section is the average rate of change. Not the difference quotient, but between two different points. Average rate of change. It's the slope of the secant line. So for example, if we have a function f of x, and we have 2 points P and Q, but this time this is x1, comma, and this is x2, comma. If we have x1, what will be the y value once we have x1? How do I determine the y value? If I have 5, how will I find the y value? We did that a few minutes ago. If I have 5, yeah, but how do I determine the y coordinate of the point? If this is 5, what will that be? Correct. So this is f of x1. And if I have x2, what will be the y coordinate of q?
F of x2.
Yes, this is very important to remember. I wish everyone would remember that. This is crucial. So now the average rate of change is the slope of this line. Average rate of change between P and Q. Average rate of change between P and Q is just the slope of this line. Can anyone dictate? Average rate of change, PQ. Can anyone other than Mallory? Can anyone give us the slope of this line? Excellent. Very good. So we are given a function. Let's look at problem 16 on page 279. That's the formula for the average rate of change for a function between any 2 points. That's the formula, which is the same thing, but we use different notation. It's y2 minus y1 over x2 minus x1. Same thing, but we like to use f of x2 minus f of x1. Is that okay? Yeah. Maybe I didn't get the question.
No, I'm good. I got it.
Okay. So in 16 we are given f of x, x squared minus 2x. They are giving us x1 equals 3 and x2 equals 6. They want us to determine the average rate of change between these points. What am I missing? Or do I have everything? Exactly. So that will be f of 6 minus,
F of 3.
very good, over
6 minus 3.
very good. That's all we have to determine. So can anyone find f of 6 and then f of 3, or f of 3 and then f of 6? How much is f of 3? 9 minus 6, which is good, and 36 minus 12, 24. Do you all agree with 3 and 24? Good. So then what will be the answer for the average rate of change for this function between the given points?
7.
We have to write,
Oh, I'm sorry.
That's
I did the
okay.
whole thing.
so 24 minus,
21. I mean 3.
good,
21 left over.
over 3. So this is 21 over 3, which is 7. Just that I would like you to remember that the difference, the average rate of change has a measurement unit that consists of 2 measurement units. A measurement unit for the top, they're abstract, we don't have them here. But if this were in miles and this in hours, 7 would have been miles per hour. So the measurement unit for the average rate of change is the measurement unit for the top divided by the measurement unit for the bottom. Any questions for me? Any questions? Is this okay? Are th- Good, good. That's all I want to hear. When my students say it's easy, it makes me feel good. Good. So the last section for test 1 is 2.5, transformations. There are several transformations. So what I would like to do is present all of them but one, and then on a Wednesday review for the test the entire time. So now since I only have 7 minutes left, I'm not going to be able to, I don't think I can present in 7 minutes everything, all the transformations. Okay, so here they are. So we'll decide on Wednesday what to do. So shifts. Horizontal and vertical. Reflections. 2 types. WRT with respect to the x-axis or the y-axis. WRT with respect to the x-axis or the y-axis. And the last one is stretching, shrinking. Stretching or shrinking. Of 2 types, horizontal and vertical. So one more time, shifts, horizontal, vertical. Reflections with respect to the x-axis or with respect to the y-axis. Stretching or shrinking, horizontal or vertical. So first of all, what is the use of this? Why? Why? What does it mean? Why do I need to look at this? Can I live without transformations? Yes, quite well. Why do we look at transformations? In order to understand the function better. In order to be able to fit through a data set one of the functions that we are going to look at. But all this means nothing if I don't remember the base functions. So I can't do any of this before we go through what I like to call base or basic, whatever you want to call them, base or basic functions. In order to understand what a function is composed of, I need to know the basic functions. If I don't know the basic functions, I will not be able to, and what's the purpose of using transformations? I will not be able to understand what's happening. So what are the basic functions? There are 6, 7, 8 basic functions, and we're going to add 2 more later. So can anyone give us the simplest possible linear function?
Or no, just x.
Exactly. The simplest linear function is just x. But we need to remember how to graph it. It's a line that bisects, and I need this for later. It's a very important line. It's a line that bisects the first and the third quadrants. Is this function odd, even, or none of the above? Even means symmetric with respect to the y-axis.
No. The origin. But I thought
Yes.
that was
So the function is odd because it's symmetric with respect to the origin.
Wait, how is it?
Symmetric with respect to the origin. Well, we had this last time. Here it is. This is a function that is odd. It's symmetric with respect to the origin. We discussed that last time. Is that okay? Yes? Okay. Quadratic. Can anyone give us the simplest possible quadratic equation?
X squared.
Very good. So we graphed this again last time. Here it is. F of x equals x squared. Odd, even, or none of the above?
Even.
Of course, symmetric with respect to the y-axis. Very good. Radical. Yes. There are two types that we're going to look at, cube root and square root. So we have to remember the graph of the square of x. Does anyone remember this graph? Exactly, perfect. That's what it is. So f of x, the square of x. Odd, even, or none of the above? Is it symmetric with respect to the origin? Is it symmetric with respect to the origin? No. Is it symmetric with respect to the y-axis? No. Not symmetric. Good.
And it's still fast.
Say it again.
That's okay, I answered your question.
I couldn't hear you. I'm sorry.
I said, do we need to learn like each of these?
You need to remember the graphs because otherwise you're not going to be able to apply transformations on those. Yes. These are all from the past courses. This is nothing new. So how to graph a line or a quadratic function. These are all from previous courses. Okay, what about the cube root also here?
It goes like this. Like,
Yes, it's similar to the square root, but also it goes in the third quadrant. Yes, I agree. So this is f of x equals the cube root of x. Odd, even, none of the above? Odd. Indeed. Absolute value.
it's like a very sharp V.
V function. That's why we sometimes call it V function. I'll stop right after I graph this. It bisects the first and the second quadrants. So this is f of x equals the absolute value of x. Odd, even, none of the above?
Even.
Very good. So on Wednesday, we are going to